Ah, the last 5 before exam questions. How very exciting. Right, we don't need direction up here because we're just finding the magnitude. Therefore, we could mod the resultant force, but you know that's maybe a bit too over the top even for me. What are we going to call this? Well, I've called it Q because if you go through your list of symbols that are available to physicists, we've used a lot of them. We've gone a bit bonkers on the symbols front. So I wouldn't use F because I might want to use that as friction later on. Resultant forces, obviously sum of forces. I think Q is fairly neutral. Obviously we use it for charge and thermal energy. I say obviously, but you might not have got to that in the course yet. But we're unlikely to be using charge or thermal energy around a vector diagram, as far as you know, honest. So I think Q's pretty safe. As I said before, I've done the component off the line there so it's easy to see. Over here I've done the diagram. Do I use pencil? Do I use pen? I haven't really talked about this much yet. It's up to you. I'd use pencil personally because then if you cock it up you can rub it out obviously. Obviously I've just done the 23 here, added to the QX component, QY, that's the thing I'm trying to find. Come down here. Obviously, having slagged off surds earlier, I did, however, admit that we can use them as a stage. So it's perfectly okay to leave them as a stage. As it is, do not worry about significant figures. As you can see, I've put the units here. It's just a personal, glitch in my brain. But I worry, because I'm very, very stupid, that when I do long solutions, although they're not that common now, but they used to be when I was a wee nipper, I'd lose track of what the various numbers were. Whereas if you bang, newtons on the end of it, at least you know it's a force. Again, it's up to you. Do we really need, this going up the other side? I think the examiner should be able to work out that they do that, but it helps them, so maybe so. Again, Pythagoras' theorem, and just to round it off, we've done a value substitution here because obviously the numbers are small. Why faff around with symbols? So what a lot we got out of that easy question. Let's hope this final 5 doesn't break the hour barrier, shall we? Right, next one. Okay, this is fairly straightforward. We're doing obviously the direction now. Call it theta. As you can see, it's to the vertical, so slap that in your diagram. I've done the classic subtraction here. And again, as you can see, I've put my O and my A relative to the angle, which hopefully will stop me from cocking it up later. Just one thing about this, I can't mention this everything I want to talk about in the earlier walkthroughs because I'd never get through them. I've no idea really why I've done the biggest arrow in the world there. I'm still going. I'm talking about it and still going. Oh dear, I need some help. Look, what I've said here about habit is, as you can see, I tend to pick to the right as plus and up as positive as well. As you saw in a couple of the earlier questions, that got me in a certain amount of trouble. I ended up having to have minuses in the answer. But as a general rule, if you're not clear from the diagram straight away which direction should be which in terms of keeping the thing you're trying to find positive, I'd stick to a habit, because then at least you're in your comfort zone and you can deal with it. Whereas if you start chopping and changing between things, well, that's where careless error lies, doesn't it? This is particularly true with projectiles. As you'll see later when we do projectiles, I'm a big fan of always taking up as plus, rather than faffing around changing the direction. But up we come. Last thing, value substitution. Yeah, lovely. Not a huge amount to say about this. Couple of things though. Have I gone a bit OTT in terms of my pre-solving here? Maybe. Maybe I don't need all this. But nobly, I've taken the hit for you to show you how to do it. What a lovely man I am. I'd actually forgotten just the thing I've just talked about. I have chosen the wrong direction, but as you can see, the math saves me. Come up here. I only need magnitude if you look at the question, so no worries about angles or anything. But I do need to remember to put this to the left, because as you can see, I chose right as plus, and it's minus. again, no need for significant figure worries here because it's only a stage and I've put the unit. Come over to the other side now. Last thing, symbol substitution. And as you can tell by now, the reason isn't due to this, it's not due to fx, it's due to fy. That's a big old number to put in, so just substitute it as a symbol. Question 4 is a little bit sneaky. It doesn't look it at first. This looks fairly untoward. A body is at rest, so you're thinking Newton's first law and you're all ready to go. But hold on a second. If you've done higher level physics like A2, come down here a second. Isn't it possible for something, for example, that's doing SHM, simple harmonic motion, isn't it possible for it to kind of be at rest but actually obeying Newton's second law? Because it's accelerating, isn't it? Now, if you're just doing AS and this terrifies you, oh, it's just a bad dream. You never saw that. Don't be frightened of A2. You'll be all right. But if you're doing A2 and that causes you a problem, that's why I've done this. So here we go. I've actually firmed it up and said, yep, it's at rest and it is experiencing zero resultant force. So it's removed that ambiguity. We need to find this angle. Now look, this is slightly fiddly. It's not too bad, but it's a little bit fiddly. If it's got zero resultant force, it's got zero resultant force in any plane. That means that this component here of this 8 Newton going through that angle, and this component here of that 8 Newtons going through that angle must be equal and opposite. Well, the only way those two can be equal and opposite is if these two angles are the same. And if those two angles are the same, then clearly I can pop something through there and that divides it in two perfectly. Do the geometry. So I'm hoping that makes sense because we're going to use it down here. I'm picking up as plus, which makes the 12 minus, obviously, because it's down. But here's the theta over 2. If you just come back up here and look at the diagram, this here, this angle is theta over 2, isn't it? As is this one. And I'm going through it, so it's cos theta over 2. That gives me, when I multiply by 8, each component of these 8 newtons vertically. And because there are two of them, I could have that plus that, but let's just multiply it by 2. So there's my equation. If you follow it through, out pops 83 straight away. Some people would prefer maybe to actually do it as separate, angles and then multiply by 2 at the end. It's up to you. I personally think that, if you're getting good at physics and that's the plan, you should be able to cope with that. It's our last 5 together. Can we still be friends afterwards? Now look, we're just about to get stuck into examination questions, which is good because this is starting to look an awful lot like a typical examination question. Although I haven't described it as such, I've labelled it Q to be consistent with what we've done before. This is actually the weight, isn't it? Let's be honest, that's the weight acting down. Here's F, probably friction. And so this is the kind of setup you'll get, particularly if you're doing M1 in mathematics, mathematical mechanics. There's loads of slopes. It's lovely. Honest. So look, body is at rest. Newton's first law, I'm thinking, yep, confirmation, Newton's first law. We need to find the angle and hence the magnitude, so we don't need the direction, of F. The and hence implies this one first, then that one. I'm just going to put this angle in its place that's useful, as we've discussed before. So which one do we do first? Well, it's pushing us towards theta and then F, and that's the only way we can go, because we just need one unknown. If we go parallel to the slope, in order to get QS and say it's equal and opposite to F, because there's no resultant force in any plane, okay, that's not a good 90 degree, but never mind. I've got two unknowns, because in order to get QS, I need to go away from theta, but I don't know theta. So it's no good me trying to work parallel to the plane. First of all, not going to happen. So we need to work perpendicular clearly. Bingo, we're in. We've got the 10. Cos theta to go through the angle is equal and opposite to 5. And that is how it works out. I've taken out of the slope as negative for neatness again, which makes this positive. Hopefully that bit makes sense. Last bit and then we're off. This isn't going to take too long, obviously. We've worked out that theta is now 60 degrees. If you glance up at your diagram, obviously I've had to move what's on the screen down. You can see that we've got F up the component of Q down the slope down, and in order to get that we need to go away from the angle. So we're going to use sine 60. They're obviously going to be equal and opposite because the resultant force is 0. Lovely. Hurrah! Well, my friend, that is it. We've consolidated, hopefully, all the stuff from the tutorials on scalars and vectors. Now, examination questions. So this could get a bit frisky, couldn't it? I'll see you in those after you've had a strong cup of tea, a lie down, and maybe a break. Go on, reward yourself. Maybe go and play a game of shove piggy shove, or perhaps rolling a hoop around your waist. Ah, the games of my youth. Toodle pip.